All right, let's start with writing the formula for the compound that is going to form between magnesium and fluorine. I need you to start getting into the habit of asking yourself this question. And the question is, what kind of bond is going to be formed between the magnesium and the fluorine? Ionic. Okay, and right now it's going to be easy because these three examples that we're going to do together are all going to be ionic. However, what's going to come down the pike is in the next section we're going to look at ones that are ionic and covalent, and they have different rules. So with the ionic one, there's two questions that I could be asking you to do. I can ask you to draw the Lewis dot diagram for the compound of magnesium and fluorine together, or I can ask you to write the formula for magnesium and fluorine together. Okay, let's start with the Lewis dot diagram, even though not every time. The only reason I'm doing that is because every once in a while on a question they'll say, write the Lewis dot diagram for the compound that forms between magnesium and fluorine. So we have to practice it. It doesn't mean every time you write down magnesium and fluorine, you're going to have to do this. So magnesium is going to have 2 valence electrons. Fluorine is going to have 7 valence electrons. And again, I'm not going over where those are coming from. I'm hoping at this point you know. You're going to show me the movement of electrons from the metal to the nonmetal. Now, fluorine can only accept 1 electron. So what do I need to do? Add another fluorine. And it has to be fluorine. You can't arbitrarily just pick another one. It's got to be fluorine. And then we'll show the other electron going there. Okay. Then what we will do is we will take, I'll draw it in blue, the magnesium that now has no electrons of its own. We're going to put that in brackets and put the charge on it. Its charge is a +2. The fluorine, which now has 8 electrons around it, 7 of its own and 1 that came from the magnesium. So I did that in different colors so you can see it. That fluorine gained 1 electron and then it became a -1 ion. And then we need 2 of these fluorines. So because I'm on the magic of an iPad, I can just do that. You would have to actually write it. Okay, go.
When am I allowed to write the little 2 on the bottom of the
Okay. When that little 2 called a subscript, right? If, let's say I wanted to be lazy, I could actually take this and I could put a 2 here. It just means there's 2 of whatever's written in front of it. So, yes, you could put a 2 there. You could put 2 of these fluorines and 1 of these magnesiums. Okay? And then when you write the formula, okay, you know that there's a magnesium. In the formula, you don't have to write the charges, but you have to know that they're there. Okay? And fluorine, there's going to be 2 of them. And again, I didn't write the charges, but I know that it's there. So this is the formula. This is the Lewis dot diagram. Okay? In the Lewis dot diagram, the reason why I was having you write it all out is because I wanted you to see. Here, let me put this again. No, go away. I don't want that too. Okay. Let's get rid of this 2 and this 2. Okay, now we've got it. The reason I had you do it this way is because I need you to understand, and I'm going to stress this, that these numbers, this 2, this -1, and this -1, have to add to 0. Okay? And that is because this entire compound has no charge on it. It's not an ion. It's a compound. Okay? It's a salt because it's ionic, and it has no charge. Do you understand that? Okay. And that's why I'm having you write them out. So I need 2 fluorines for every 1 magnesium. All right, what is the formula of this going to look like? Lithium and oxygen. Oh, where's James today? Alex, do you know? Hope he's not sick. James, we miss you. I said that on the tape so he can watch us. Who else is missing today? I think that's it. I didn't ask you to draw the Lewis dot diagram, but I'll just draw it so that you can see what's happening. Okay? I'm going to need 2 lithiums to complete oxygen's octet. So what is the formula going to look like, Christina? Do you have any idea? Oh, good. Li what? 2 and an O. I need 2 lithiums and 1 oxygen. There are charges on this lithium. It's a +1, and this one is a -2, even though they are not written when we write the formula down. Just know that they are still there. I also want to point out that in an ionic compound, and I'm going to have you do this in a few minutes, okay, in an ionic compound, it is always made of 2 parts. It's going to be made of the cation, which is the lithium, and the anion, in this case, which is the oxygen. Any compound that is ionic is made of 2 parts. It is made of the cation and the anion. Well, I guess I shouldn't have just done the anion. Okay? Do you understand that? Okay. Aluminum and sulfur. What's the formula? Oh, Cam is not here today. Oh, there he is, hiding behind Caleb. I didn't see you back there. How you doing, Dylan? You good? Okay. You know this? Easy peasy lemon squeezy? Good. Diego, you know it's easy? So far, so good? Okay. We're going to level up in a few minutes, so I just want to make sure everybody's okay. Leveling up. You know, like in a video game, we're going to level up. All right. Do we have we have an answer for this? Sean, do you know the answer? You need help? You need to, like, use your, like, phone a friend or something? Adrian, go ahead. Help him out. Oops. Yes, I just need a pen. Aluminum with a 2 and sulfur with a 3. Okay? Now, there's a shortcut. I showed you yesterday, right? The little shortcut. Let's do the shortcut just so that you can see how it works. This aluminum is going to form a +3 charge. I know that because I'm looking at the periodic table, and in the upper right-hand corner, it tells me that aluminum is going to lose 3 electrons. It's going to form a +3 charge. Sulfur is going to be a -2. It's going to gain 2. So the easiest way to do these is to do what we call the crisscross method. We're going to take whatever number, not the sign, just the number, and we're going to push that number down to the opposite. So if that 3 is on the cation, then that becomes the subscript of the anion. The 2, which is on the anion, is going to become the subscript for the cation. Good? Okay. Any questions on that? Sean, do you understand now? Do you need to move up? You're really far away, so sometimes moving up, I know this is the weirdest thing ever, but sometimes moving up does help. Just saying. Keep that in mind. Okay. Let's go back to the same 3 examples, and we're going to name them now. So we wrote the formulas. This is simple formula writing. Now we're going to name them. Okay, so when we name these binary ionic compounds, binary because there's 2 elements. Okay, 2 elements, so we call them binary ionic compounds. We're going to start with the cation, whatever the cation's name is, and we're going to leave it alone. So in this case, it's going to be magnesium. Am I on a good pen? The anion, which is the negative ion, the negative ion is always written second, it's always on the right-hand side. We're going to take whatever that thing is, in this case it's fluorine, we're going to take the end off, and we're going to add "ide" to the end. So binary ionic compounds end in IDE. So this now is known as magnesium fluoride. Not magnesium and fluorine, it's magnesium fluoride, telling us that they have combined. Okay? Alright, let's go to the next one. This one was lithium and oxygen. So what is its name going to be? Lithium oxide. Easy peasy. Oxygen becomes oxide. That is not very neat, Kaufman. Let's try it again. Lithium, oxygen, oxide. Okay? Good? Alright. Aluminum and sulfur. Aluminum sulfide. Beautiful. Give yourself a gold star. Alright, so now you know how to write binary ionic compounds, and you know how to name binary ionic compounds. Simple binary ionic compounds. I have been very, very selective in the ones that I have given you. Okay? The reason I have been very selective is because, you know what, let me stop the tape for a second. Let's practice a few of these and then I'll come back to this. Yeah, stop the tape. Stop the tape. Alright, after I give you the answers, we'll stop it. Alright, I'm going to do this fast. Please check your answers. I walked around. 99% of you are on the right track. If you still need help, you can come after school. I can help you out a little bit more. So potassium is +1, bromine is -1, and you're going to get KBr. Calcium is +2, oxygen is -2. When you do this, okay, I'm going to make my pen even a little bit smaller so that I can fit it in here. Okay, look, Ca +2, O -2, this 2 goes down here. This 2 goes down here. That's called the crisscross method. You have to do the crisscross for every single time you write an ionic compound. Okay? Then, because these 2's, and I'm going to use a highlighter, these 2's are the same number, and they're a ratio, we're going to reduce them to the lowest whole numbers. So we're going to end up with CaO, 1-to-1 ratio. 2 to 2 becomes 1 to 1. Okay. All right, magnesium sulfide. Magnesium is a +2, sulfur is a -2. Same exact thing happens. Magnesium with a +2, sulfur with a -2. 2 goes down here, 2 goes down here. We have to reduce them, so it becomes MgS. Zinc is a +2, chlorine is a -1, Zn +2, Cl -1, so that becomes ZnCl2. That 2 came down here. The 1 went down here. So ZnCl2. Any questions on that one? Sodium +1, sulfur -2. That 1 becomes the subscript for the sulfur. The 2 becomes the subscript for the sodium. And you get Na2S. Strontium is a +2. Fluorine is a -1. SrF2. Questions? Lithium is a +1. Oxygen is a -2. So the 1 is the oxygen subscript. The 2 is the lithium subscript. Li2O. Potassium is a +1. Nitrogen is a -3. I know nitrogen has a lot of choices. Use the top one. That's the most common. There are going to be rules for when to use the other ones. We haven't gotten there yet. So just use the top one. You're going to end up with K3N. Sodium +1. Phosphide is a -3. Na3, that's a 2, Kaufman. Na3P. It looks like NAP. Okay. Aluminum chloride. Aluminum is a +3. Chlorine is a -1. AlCl3. Calcium +2. Nitrogen -3. Ca3N2. Better just check myself on that one. Yep. Okay. Aluminum is a +3. Oxygen is a -2. Al2O3. Magnesium +2. Phosphide -3. Mg3P2. And then aluminum is a +3. Sulfur is a -2. Al2S3. How did I do? Everybody got those? You understand? Okay, good. All right, now on the second page, a lot of you went ahead, so I didn't have to stop and say, go ahead and do that. We're going to name them. These are binary compounds, and they're simple binary compounds. There's no funny business going on here. Funny business is coming your way, okay? When we do a binary compound, the first part, the cation, which I had you highlight, and this is going to be the K, okay, keeps his name. So he is potassium. And the anion, which I'll make it yellow, okay, gets its name changed to end in IDE. So this is potassium chloride. Lithium oxide. Calcium bromide. Lithium hydride. Make sure you wrote hydride and not hydroxide. Okay, hydroxide is a polyatomic ion that has oxygen and hydrogen with a negative charge. That's coming, but right now it's binary. There's only 2 elements in this compound. And remember, you can know that there's 2 elements because it's the number of capital letters. If there's 2 capital letters, you've got a binary compound. Okay? Alright, I want to just change this up just a little tiny bit with a different color because it's getting boring. Magnesium Somebody give me the end of it because I can't see through my hand. Bromide. Potassium. Oxide. Thank you. Zinc. Oxide. Strontium. Sulfide. Calcium. Sulfide. Okay, I'll put the rest of them up. I'm not going to write them all. Aluminum sulfide. Zinc fluoride. Silver nitride. Check your work. Sodium fluoride. Barium oxide. Sodium sulfide. Aluminum bromide. Lithium nitride. Potassium fluoride. Strontium iodide. Magnesium oxide. Aluminum oxide, and calcium hydride. Everybody got those? Okay. I also asked you to highlight. Highlight the cation. I'm going to keep them the same color. Okay, highlight the cation. Highlight the anion. Do not highlight the subscript. The subscript came from whoever it's attached to's charge. So this 2 is telling me that sulfur had a -2 charge. Got it? All right. Let me just stop this for 1 second. That stuff. Okay, so for the video, I just wanted to put the answers. So if you're looking at them, you have the answers for the questions. So there's the top half. Pause it if you want. And the bottom half. Pause it. Now I'm going to stop the tape so that it's not so long.